Hey everyone, welcome to the third video in our series on the reactions of Chapter 11. In this video, we're going to be talking about basically SN2, and you'll kind of see what I mean. But we're going to be doing SN2 with sulfonate esters. Okay, so sulfonate esters. So there's three main ways that we can make these. So we're going to talk about how to form them first, and then we're going to talk about uh, what we can do with them, right? So there's three different things that we can use to make a sulfonate ester. Okay, so I'm going to show you guys an example, and then we will talk about what this is going to look like. So I can use something called TSCl. This is tosyl chloride with pyridine. And what this does is it replaces the OH with something called OTS. Okay, replaces OH with OTS. Okay, so now that we've seen that, I'm going to explain this a little bit more. So we just use TSCl, right? So TSCl is tosyl chloride, and TSCl looks like this. Okay, so this is TSCl. All right, this is tosyl chloride. And all that's happened here is that this O has attached itself to this S and the chlorine is gone, right? So we have this entire group here now attached to this O. That's what OTS means, okay? So this is a fantastic leaving group. So now after we form a alkyl tosylate like this, we can do SN2 on it, right? So because OH groups, alcohols, are not good leaving groups, so sometimes we want to replace the OH with something else that's a better leaving group like an OTS, okay? So we can use TSCl to do this reaction to form this group. We can also use two other things that we're going to mention. So you can use MsCl, okay, which is a mesyl chloride. And mesyl chlorides look like this. This is MsCl, okay? And we can also use a trifle chloride. So that's TFCl. So TFCl looks very similar, except that this is a CF3 now instead of a CH3. Other than that, it is identical. Okay, so all of these things are going to do the same thing. So if we used MsCl here, this would be OMS, right? So let's do this with MsCl and pyridine. Then all we're going to get is OMS. Okay, same thing with TFCl, right? I could use TFCl and that would give me the exact same thing, all right? Okay, so again, like I said, all of these are fantastic leaving groups, all three of these. So the purpose of these, after we form them, right? So this is formation. This is how we form them. After we form them, we want to do things with them, right? Like we want to do reactions with them. So let's do a couple of examples here. So if I take some molecule and turn it into a alkyl tosylate, so I'm going to be using TSCl for this entire video, but you can use MsCl, TFCl, whatever, right? So first step, we're going to use TSCl. And whenever I use TSCl in the first step, you'll see this is chiral. The chirality doesn't change for the first step, so I just have OTS, right? So it changes the OH into OTS, okay? But now what I can do is I can use something that is a good SN2 nucleophile, right? And then a solvent, polar aprotic solvent. So this second step, this is SN2, right? This is SN2, this step here. So remember, SN2 changes the configuration. So this is on a wedge. So that means that the CN that I'm adding, right? This is my nucleophile right here, CN, CN is going to be on a dash, okay? And again, these OTS, OMS, OTF, all of those things are very, very, very good leaving groups. So we can do SN2 on things that may, like this is a second degree group that we're trying to have leave. Usually that's not great for SN2, and CN minus cyanide ions are not great nucleophiles either, but it actually doesn't matter. We can still use it because OTS is such a good leaving group, okay? So this really, really, really works well for doing SN2 reactions, okay? We can also do E2 reactions and other things with it as well, but I'm just worried about SN2 in it for this, okay? I'm just going to do a couple other ones here. So let's say that we have this alcohol. And so as a first step, I'm going to add in TSCl with pyridine. And then as a second step, I'm going to add in NaOH. So in this case, OH is my nucleophile. So the first step just changes this into a tosylate. And then the second step, I'm going to replace that OH with another OH, which is kind of strange, right? So OH is going to replace OH. But remember that it's going to flip the stereochemistry. So right now this is on a dash. It's going to be on a wedge now, right? So now I have it on a wedge. So I add NaOH in the second step. It goes in, does SN2, and replaces that, okay? So we can flip the stereochemistry of an alcohol by using this, okay? That's one thing that we can do. But there's so many other things we can do with this, right? Like if we wanted to take some alcohol and as a first step, we put in TSCl and pyridine. And then as a second step, we put in NABR. Well, now bromine is just going to replace that OH, right? So I just made an alkyl halide now. So I can replace this or change it to a CN or change it to a bromine. There's a lot of different things that I can do here, right? Finally, another important reaction that I can do here is I can actually completely get rid of the alcohol in some cases. So if I take, I don't know. Let's say we take this one. So we take this alcohol, and then we put in TSCl, with pyridine, and then as a second step, we put in lithium aluminum hydride. What this is going to do is one of these H- ions is going to come in and act as a nucleophile and get rid of this OH. So what happens if we replace OH with H? We just get an alkane, right? So with this TSCl, if I replace it with OH and then use H- ions from lithium aluminum hydride, I can just make an alkane straight from an alcohol. Okay, so I've made alkyl halides, I flipped the conversion, I flipped the stereochemistry, and I've made an alkane. You can also make ethers with this, right? So let's say we want to use this alcohol. Again, put in TSCl with pyridine. Then as a second step, I can put in some alkoxide, so OCH3. And then all that's going to do is make an ether, OCH3. So I can make ethers, alkanes, alkyl halides. I can make all kinds of stuff, right? So this is a very versatile reaction. There's a lot. This is a very easy way to add many, many, many different things to where an alcohol is, right? As well as flipping the stereochemistry of an alcohol. Okay. So as I said, I've been using TSCl in this video a lot. You don't have to use TSCl, right? So you can use MSCl, TFCl, right? Trifol groups, mesyl groups, tosyl groups, doesn't really matter. All of them are good leaving groups, and yeah, they all work just as well for these reactions. So this is quick. I just think that this is very important to mention. So hopefully this was helpful. And in the next video, we're going to talk about Williams ether synthesis, and that's the last video for this chapter. So hopefully you join me for that one. Hopefully this is helpful, and I will see you in the next one.